Section 5.4 Interactive Assignment Objective 2. Suppose you just received a shipment of 11 televisions. 3 of the televisions are defective. If 2 televisions are randomly selected, compute the probability that both televisions work. What is the probability that at least one of the 2 televisions do not work? So there's 2 questions. The first question is you want to find out if 2 televisions are randomly selected, compute the probability that both televisions work. So let's go over this again. We know that we have 11 televisions, but we also know that 3 of them are defective. Okay, and that's important here. So now if 2 televisions are randomly selected, we want to compute the probability that both televisions work. So the general multiplication rule states that the probability that 2 events E and F both occur is the probability of event E occurring times the probability of event F occurring given the occurrence of E. So here's the formula for that. Okay, now we're going to use the general multiplication rule for the probability that both work can be found as follows. So for the probability that both work, okay, we want to do the following. So the probability that both work is finding the probability that the first works times the probability that the second works provided that the first works. Okay, so that means that we need to find the probability that the first television works, which is the number of working televisions, which we know is 11, okay, and we're going to subtract the amount that's defective, which is 3. So we know that since 11 minus 3 gives us 8, that means 8 is working out of the total number, which is 11. So we want to find the ratio of 8 to 11. So the probability that the first works is taking 8 divided by 11, which is 0.727. Okay, now we picked our first television that works. Now we need to pick a second television that works. So in order to do that, if we pick 1 from the 11, then how many do we have left over? Well, after picking a television that works, we know now that there are 10 televisions remaining, and we also know that there are 3 that are defective. So that means now we're going to take the total of remaining, that's 3, and then we're going to subtract the ones that are defective, which is 3, to give us a total of 7, and we're going to divide it by the number that's remaining, which is 10. So now that's going to give us the probability of the second works, provided that the first works. So to find that probability, we're going to take 7 and divide it by 10 to get 0.700. Okay, now we're going to use the general multiplication rule to find the probability that both randomly chosen televisions work. And then we're going to round to 3 decimal places. So here is our formula. Okay, what we're finding here is that both work by multiplying by the probability that the first works times the probability that the second works. Okay, well, we know what that is. We know that that's the first one is 8 divided by 11 times 7 divided by 10, but we know what those decimals are. So we know that we get 0.727 times 0.700, and then we're going to round our result to 0.509. And therefore, the probability that both televisions work is 0.509. So that is our result. Okay? Now, it says, what is the probability that at least one of the 2 televisions does not work? Okay, now, the probability that at least one of the televisions does not work can be found by using a complement. Now, the complement of the probability that at least one does not work is that the probability of them both work. Therefore, we're going to use the value, okay, that was found for the probability that both work to calculate the probability that at least one does not work, and then rounding it to 3 decimal places. So we are looking for the following. We're looking for the probability that at least one does not work. Okay? So by doing that, we're going to take 1 and then we're going to subtract the probability that both work. And we know that from our previous result, we had 0.509, and 1 minus 0.509 gives us 0.491. Therefore, the probability that at least one of the two televisions does not work is 0.491. Okay, and if we look at our results, there's our results. Probability that both televisions work is 0.509. The probability that at least one of the two televisions does not work is 0.491.